quick examples, and then we'll flip here. So what about something like this? We've got an area function, f of x. We've got some f of x is defined. We want to know for what positive value of b is the area function equal to 0. Okay? So what do you think? What could we do here? Is this a first fundamental theorem or second fundamental theorem issue, do you think? What do you think? Actually, this would be a first, right? Because there's no involvement of the derivative here. We're just looking at total areas. We want to set the total area equal to 0, but it's kind of a weird one because we're trying to find this value of, this value of the variable that's the upper limit. This is how it was written in, I can't remember where I got this. I think this was a sapling problem, and it was written this way. It probably should have been written with a dummy variable there. But sometimes people just don't use dummy. Sometimes they don't use the t, they just use x for both. Okay, so this would be one where we've got to actually take this antiderivative and evaluate it from 0 to x, and then we'll solve for x. And the value of x that's going to make the area equal 0 we'll call b, right? Okay, so what's this going to give us then? We've got integral of 3x squared minus x cubed dx. Actually, this is similar to one. You're going to get one like this. I made this one up, but it's very similar to one that you're going to see in sapling. So what is that antiderivative? Right? And we want to know when is that equal to 0, right? Well, at 0, that's going to evaluate to 0, isn't it? Right? So really, this is our expression, isn't it, if we evaluate this at x. So now we've just got to solve that equation. What can we do right away maybe to make this a little bit simpler? Factor out an x cubed, and maybe factor out an x cubed over 4. Or how about if we just clear fractions and multiply through by 4? So then I end up with 4x cubed minus x to the 4th equals 0. I can factor out an x cubed, leaving me with 4x minus, 4 minus x. Right? Did I do that right? So what are my solutions then? And we wanted a positive value, so that's it, isn't it? that's the value where our area is equal to 0. Okay, how are we doing? Thumbs on that? Is that good? Okay. Okay, how about this one? So this one's saying just in general now, we're just going to say a is just some positive number and f of x is ax squared minus x cubed. For what value of b is the area function equal to 0? That's the same thing, isn't it? We would evaluate this integral. And a is a constant, right? So if I evaluate this integral. Is that one? You guys are welcome to do that. I mean, how many people are interested in doing the engineering one? I think they're really good. Do you guys know what it's about? Did you talk about it in your advisory? Man, I'd encourage you to do it. And I'd be willing to just pause things a day if that's something you want to do. Let me... I'll just tape the rest of this. We only have one more example to do. It's no big deal. What? What's that? Oh no, they told us this morning you can still do it. Yeah. Yes.
So which test are you going to put out first?
Which test, meaning the?
Like the one with the formulas and the one with the problems.
Oh, I'll put them both out. You can choose whichever one you want to do. Yeah.
So the first test is just all the formulas?
Just the derivatives. Yeah.
Oh, okay.
Yeah.
And the second one is actually formulas?
Right, right. We'll go through, when I'm done with these examples, we'll flip-flop and I'll go through some sample problems up here. We'll just continue to kind of review for it a little bit. Yeah.
How long do we have to do the test?
Well, I mean, I'll give you plenty of time. I'll give you a couple days in class to do it. And then any other time, you can just, whenever, just advisory, work days in here. So, yeah. Okay, so this would just be solving or evaluating this integral, right? Integral of ax squared minus x cubed dx from 0 to x, right? And then what's that going to be? Just a over 3x cubed minus x to the 4th over 4. Evaluated from 0 to x. At 0, it's all going to go away. So I'm just going to get that equals 0, right? So what could I do to maybe simplify that? I just got to solve that equation. Ideas? Say it again. Yeah, get clear fractions. Yeah, multiply both sides through by what then? 12. Yeah, good. So if we distribute a 12 through, we're just going to get, what, 4ax cubed minus 3x to the 4th equals 0. So now I could factor out my x cubed. And we want positive values of b, and we said a is positive valued, right? So then this solution of 0 we're not really interested in. But here we're going to get what? 4/3 a. Good? Okay. So good? Okay. Last one. This is kind of a cool one. So what's the value? What value of b that's greater than -1 is going to maximize this area function? Okay. This is a pretty good problem. I like this one. So the same kind of thing, right? We've got to find the antiderivative, and then we're going to have to maximize that function for values of x greater than -1. So this is going to end up being a table problem, isn't it? Right? Now, we could be smart about this, though, because the derivative of this area function is just that, right? So we don't even really necessarily have to take this antiderivative. I mean, we can, right? But when we build our table, you see what I'm getting at here? When we build our table, we'll just call it f. We'll just call that our area function, okay? This is actually, we know that the derivative with respect to x of f is just equal to x squared minus 4x plus 14 by the second fundamental theorem, right? So then all we have to do here to find our critical numbers is just set that derivative equal to 0. So what are the critical numbers here? If I set this thing equal to 0 and solve, what's that factoring into? X. Boy, does that factor? Man, did I mess this up? Because I think it's supposed to factor.
Make the 14 and 12.
Yeah, that's probably what I was meaning to do. But even that's not going to do it, is it? It's going to have to be a negative 12. Okay, let's do that. We'll just make it a negative 12. Okay, so now that's going to factor into what? X minus 6 times x plus 2. So we're getting zeros of 6 or negative 2, but negative 2 is not in our domain, right? Our domain, we want values greater than negative 1, so we're looking at something like that, right? Okay, I hope this works. I really hope this works. I thought that, gosh, huh. Okay. Man, this doesn't seem like, it seems like I copied the wrong thing, because I thought it was a cubic too that I was doing, but maybe I'm wrong. So 6 is my critical number, where we get a 0 of the first derivative. Okay, we'd want to go ahead and take a second derivative problem. I mean, we could use the first derivative test, that's fine. In fact, well, pretty easy to take a second derivative though, isn't it? Right, our second derivative would just be 2x minus 4. Okay, and so we can evaluate that at 6, and we get okay, that's giving us positive answer, which is not what we want. Dang it, I messed this one up. I really messed this one up. What the heck? I thought I had this all figured out. I know I did, because I did the problem, but that doesn't look like the one.